Hey guys, this is your horizontal projectile example problem. Person running off a diving board horizontally. They don't jump off the diving board, they just kind of run off of it straight out. So as to be perfectly horizontally and not at an angle. So the question is, if they run out horizontally, and you could draw this diagram showing that as I say this, if they run out horizontally, how far out in the water will they land? And the problem gives you a couple givens. They say the speed they run at, and I'm going to label that on my diagram, VIX, their initial speed in the x direction. Since they run out horizontally, the speed they run at is an x velocity. And that speed is 4 meters per second. They're running pretty fast off the diving board there. The other given that's told to us is that the board they run off of is 15 meters above the water's surface. So we're going to label that. That's a distance. In which direction? The distance, that's how high up they are. So it's a distance vertically, or in the y direction. We're going to label that dy on our diagram. Is 15 meters up. Pretty high up. And the question asks, how far out do they land in the water? They leave right over where the water surface starts, and then how far out do they land? How much distance horizontally out do they land? That's a distance in the x direction. So we're going to say dx equals question mark right down there. Alright, and that's what we want to solve for. How far out do they hit? Notice that all our V's and D's have an X or a Y next to it. So to solve this problem, we're going to go to our kinematic equations, but we're going to use them in a little bit of a new way. First, what I want you to do to solve all horizontal projectile problems is make an X column and a Y column. There's calculations that are done in the x direction, and there's ones that are done in the y direction. Alright? And you could start off the columns with 3 variables all the time. In the x direction, we know our acceleration is always, there is no acceleration in the x direction. Objects move at a constant speed that way, so 0 meters per second. And our y acceleration is the same for any projectile, also just negative 9.8 meters per second squared. So you always know the acceleration in the x direction, the acceleration in the y direction for any projectile. But there's another given, a third one, for an object that is launched horizontally that we always know. Notice that our diver leaves with an initial x velocity when they first enter the air, because they run off straight out or horizontally. But what is their initial y velocity equal to? Well, if they run straight out horizontally, initially they don't have a vertical speed. Just like a dropped object that doesn't have an initial vertical speed, their initial y velocity is also 0 meters per second. Dropped objects and horizontal projectiles share many properties. So in our y column, we could always say, because it's launched horizontally, there's no initial y speed. I want you to star these 3 givens, because the star is going to mean always true for horizontal projectiles. So let's write down the other givens that the problem tells us. They start out with an initial x velocity of 4 meters per second. And they start off at that height, that dy of 15 meters. Alright? So that's all the problem really tells us. Alright, so we have to go ahead and solve for the unknown now, which is the range, or dx. What is that? Okay, so what we need to do always before finding whatever we're looking for in a horizontal projectile problem, we have to find time first. And the reason why is the time for the object to fall in the y direction is always the same as the amount of time it takes to go out while it's falling. So time is shared, write this again, t, or time, is shared between both x and y direction. So the only variable in our kinematic equations that is common between the x and the y direction is time. Alright, so what we're going to do to solve for ranges, we're going to first treat the y direction like a dropped object, and we're going to solve for t in that direction. So let's put a question mark right there in the y direction, solve for t. We have to choose an equation to do this. Notice that out of the 5 variables that are included in the kinematic equations, the only one not mentioned in the y direction and that we're not looking for is vf. So whatever equation we choose has to have an acceleration, an initial velocity, a distance, and a time, but no vf. So you could put a big X there. So what's the only equation missing vf is the first equation. So we're going to choose that, but we're going to write it a little differently. Every time we do horizontal projectile problem, you have to write not just d, but dy. Not just vi, because was it vix or viy? If it's in the y column, it gets a y. viy times t. You don't have to write ty, because time is shared between the x and the y direction. So a half ay t squared. Great. So let's go ahead and solve. Forgot a negative there for dy because it's dropped. So it's a negative 15 meters it covers. viy is 0. We're going to solve for t. A half, negative 9.8 t squared. 0 times t is nothing. So negative 15 equals negative 4.9. That's a half of 9.8 t squared. Divide both sides by negative 4.9. And you can do this on your calculator. Time is 3.06 seconds. So always first solve for time. It's another important point when we look at projectiles that are horizontal. Solve for time first, and then you could look for range, what you're really looking for there. Alright, so you're not always going to solve for time in the y direction first. Say you might be looking for height, dy. Then you would have to solve for time over in the other column and look for height. But whichever column you solve time for, you're going to finish the problem in the other column. So we've found time in the y column. Now we're going to calculate what our final answer for range in the x column. Alright, so we have a vix, a dx, ax. We could say vfx should be there. And what other was our fifth variable would be time. Oh yeah, we just solved for that. You know that now. It's 3.06 seconds, so we could add it to the list in the x column. It's shared between x and y. One thing you could say in the x direction, since there is no acceleration, the final velocity is always the same as the initial x velocity. So vix and vfx are equal. Alright, so that really actually helps us solve. You're going to still use the kinematic equations, but which one could you choose? You really could choose any one here. I would go for one that has distance in it. So not the second one. Let's go for the fourth one. Why not? So we could say, no, let's do the first one just like we did before. The truth is that with horizontal projectiles, you really could just use the first equation all of the time, right? So let's solve for dx and finish the problem. Dx equals Vix, that was given in the problem, times t, which we just found, plus a half, ax, oh, there's no acceleration in the x direction. Huh, that makes it easy. Times 3.06 squared. Well, because there's a 0 in the second term, that whole term is equal to 0. And dx is simply Vix, which is 4 meters per second, times the time, or 3.06. So therefore our range is going to be 4 times 3.06. 12.24 meters is how far we land out in the water. Wow. So there's always two calculations for a horizontal projectile. One in the x column and one in the y column. The first thing you need to do is find time. And then you could solve for what you're looking for in the other column. So we found time in the y, then we found range in the x. Sometimes you're going to find time in the x and then find a height or something like that in the y direction. All right, so remember our stars, right? Always true. What we start over here is that we've got ax equals 0, ay equals negative 9.8, and viy equals 0, like a dropped object. All right, so go ahead and try the next problem and use this one as a guide.